All right, guys, so we're on the home stretch. This is part 4. So our question is, how much of the Earth is covered by water? It's going to help us estimate population proportions using the state, plan, do, conclude method. So what proportion of Earth is covered by water? We'll investigate this question by taking a random sample of locations on a globe. So what I actually had my students do last year, I had an inflatable globe and I had them tossed around the room until it had been tossed, and that was the randomness, and then caught, and wherever the person who caught it, their pinky was, we looked to see whether that was water or land. And we kept track over here. So I kept track. Water came up 34 times and land came up 16 times out of 50. It was quite fun. Sorry, guys. I wish we could do more fun stuff, but online is hard. Okay, so how many locations did our class sample? We did 50. And how many were in water? It ended up being 34. Okay, so we need to calculate first, of course, the proportion of locations that were in water, p hat. That's my 34 out of 50. And I'm going to try to make that a decimal. So 34 divided by 50 gives me 0.68. All right, the 0.68 is just a little bit easier to work with. Okay, so now, here's what your homework will ask. Construct a 95% confidence interval to estimate the proportion of the Earth that is water. So you'll have to know how to find your sample proportion, first of all, and then you're going to use this strategy, right? So this might be a piece of paper that you print out a blank one for yourself, just this state, plan, do, conclude. This is a great reference for all of your homework problems. Asking you to construct confidence intervals. So the first thing you need to do is state the parameter you want to estimate and the confidence level. So our parameter comes from the question. I'm trying to construct a 95% confidence interval to estimate the proportion of the Earth that is water. So that's it. And my parameter is P equal to the true proportion of Earth that is water. That's it. That's my parameter. And then my confidence level, which also comes from the directions, my 95%. Okay, so then it says plan. I had to state, now I plan. I'm identifying the appropriate inference method and check conditions. So you may not have heard this before, but this is just the name of the confidence interval that we're actually calculating. So this is new. The name of our procedure is called a one sample, because of course we have one sample. Later we'll do 2 samples, but a one sample Z interval. The Z comes from how we calculate our critical values. We use Z-scores for P, right? Eventually we'll do this for mean, so it'll be for mu. So that's the name, that's new. All right, then we have to check our conditions. The first one, do we have a random sample? Well, as we were throwing this ball around, it spun through the area. That seems pretty random, so I'm gonna say yes, we have a random sample. Okay, number 2, we want to check that we have a binomial setting. We check bins. It's either water or it's not, right? And then is it independent? We're going to check that 10% condition. So n is equal to 50. Is that less than 1/10 or 10% of all possible locations that we could have chosen? Absolutely, right there, more than 50 locations on the Earth. And then we check n is 50, it's set, and the probability of being in water is the same each time because it's randomized. Okay, so then number 3 is whether or not we can use our normal curve to figure this out. So of course we check large counts, which means we need to multiply n times p hat, which we actually found p hat by already knowing the number of successes we had, or the number of locations in the water. It was actually 34. So we can just go ahead and write that down. That is greater than or equal to 5, so that's good. So the number that do not fit what we want, the number of failures, would be 50 minus 34. So what is that, 16? Yeah, that's also greater than or equal to 5. So we're good to move forward. Okay, so if the conditions are met, we can move on to the next step, the do step. This is where we actually calculate the interval. So we're going to start out by just writing our general formula. I know this is kind of annoying, but I really want you to write it every time because I want you to remember it. And I want it to be clear that this works for all intervals, not just for population proportions. So it'll continue to work for us. point estimate plus or minus margin of error. Then you have to think to yourself, what is the point estimate for this confidence interval? So I can fill into the specific formula. Well, it's p hat plus or minus my critical value, which for this case is z star, and then times the standard deviation, which is my p hat times q hat divided by n. Then I show how I'm plugging the numbers in. You have to do this. You have to show the work. So I'm showing that I'm plugging in 0.68 plus or minus z star. Okay, wait, I have to think, how did I get that critical value? Well, if it's for a 95% confidence interval, that is listed either in my notes or again in table A. Confidence level of 0.95 gives us a critical value of 1.96. So that's what we use here, 1.96 multiplied by our value of 0.68. This time, instead of writing 1 minus 0.68 for q hat, I'm just going to do it in my head. It's going to be what? 0.32. And then I divide by n, which in this case is 50. Okay, let's multiply out this right part. This is going to be 0.68 plus or minus 1.96 times the square root of 0.68 times 0.32 divided by 50. All right, I get 0.129. Okay, so I have 0.68 plus 0.129. I'm choosing to round to 3 decimal places this time because that's what your book suggests. All right, 0.68 plus, I should probably do minus first, get my lower limit. So minus that value, I get 0.551 if I round to 3 decimal places. My lower limit, and then 0.68 plus that standard deviation value or standard error, 0.089. Sorry, 809. Okay. So there's my confidence interval. I do want to point out sometimes your book also lists it as 0.551 is less than p is less than 0.809. If you feel better writing it that way, that's fine. Go for it. Okay, so once we have done the calculations, of course we have to interpret. And I warned you before, the interpretation is the most important part. So make sure you get it correct. It's that sentence we should know by now. So we are 95%, that was our confidence level. We are 95% confident that the interval from 0.551 to 0.809 captures the true, and then whatever our parameter is, which in this case is a proportion. Remember, we stated it up at the beginning. So the true proportion, where is it, of Earth that is covered by water, or that is water. True proportion of Earth that is water. Please excuse my cat meowing in the background. Okay, that's it. That's our problem. So number 3 is what you will be expected to do for your homework problems on confidence intervals. I think I assigned you like 5 or 6 of these, but since you don't have to write out all this typed stuff, right, you're just writing what's written here, it goes a lot quicker. Okay, so I'm gonna do our last video next for the big ideas and check your understanding on the back.